After hearing about this hot end for almost a decade, it seems like, you're finally going to get your chance to get your hands on the Pico Hybrid. What's up everyone, Chris here, and yes, the Pico Hybrid Hotend has had an interesting past. I've seen videos online that are 8 years old now talking about this design. The whole thing started with B3 Innovations. They didn't quite get this product to market, but then a new company called Metaform picked it up several years ago, and now they're getting ready to finally release it. By the time you see this video, you should be able to purchase one and get your hands on it. Now, my buddy Chris Russell talked to me about Metaform and what they were doing, and I found out they were located in my hometown here in Kansas City. I even got to go to their facility to see how they make these things. So what we're going to do today is check out what comes in the box, why you might want the Pico Hybrid Hotend for your 3D printer, and what advantages it might have. So let's jump right in and see what you're going to get in the package when you buy one of these. So here we go. We have an attractive looking metal tin. I really like the way this thing's packaged. Got our logo card. It is important to note all the metal parts on these are machined right here in Kansas City in the USA. We have your hot end. It does have the heater attached to it. We've got our hot end cooling fan. And then over here on the other side, we have our thermistor. We'll take out the foam. On the second level, we have a 3D printed part. We've got a little bag of tools, couple of wrenches, Allen wrenches, as well as a small screwdriver. We've got a linear voltage regulator. All the fans on the Pico that they're going to use stock are 5 volt. This will get you down from 12 or 24. We've got some add-on parts, a collet for 3mm filament. We have a tube here for Bowden that goes in the top. I'll show you some of these in a moment. And then some wire extensions. So the Pico is a pretty interesting little design. We'll kind of take it apart and talk about it piece by piece. The machining that is done on the Pico, some of these parts are very thin. They're pretty delicate, so you want to be very careful with it. All of the parts on here can be just hand tight. Things like the mount, they do have a grub screw, so you can get it just a little bit tighter on the heatsink so it doesn't move around. But hand tight is pretty much all you want to go. You could shear off this heatsink really easily. It comes stock with the nozzle that has a PTFE liner. This is mainly for PLA. They do have an all-metal version. We'll take a look at that a little bit later. But that tube fits right down inside the nozzle, so that will prevent any leaks. As well as the longer thread. That's going to help out too. It is a 0.4 by default. Your heatsink screws right into your heat block. The heater goes down. It has kind of an L connection. That heatsink keeps it in place. And your heat block is aluminum. You do have a flat spot down here if you want to hold it with a wrench. But remember, don't get crazy with this nozzle. Hand tight's all you need, seriously. And you can take your mounting groove off here. You can mount these however you want. These do stay really cool. They heat up really fast. They cool down really quickly. And that's just because of the way it's designed. The metal is very thin. The heatsink is made out of stainless. And if in the stock kit you do get the groove mount like a V6, this is also aluminum. The nozzles are nickel-coated brass. And if you get in close on that heatsink, you actually have cross-drilled holes. That also helps dissipate that heat, so you can get cooling in there just a little bit easier. The PTFE liner, as well as that all-metal nozzle, they go up inside here. So it's kind of like it's its own barrel. So that just screws on to the heat block. Your nozzle, of course, screws in from the bottom. And then you can see it there populating those cross-drilled holes. That goes all the way to the top of that heat sink. And that right there in itself is the whole hot end. You can mount it whichever way you want. They just happen to give you the groove mount. So with that being said, this is the smallest hot end design that I have ever seen. Now your thermistor, this is just a 100K thermistor, but they have a brass fitting with a spring on it to make it a little bit more versatile. And you won't break it as easy as a lot of those bead-type thermistors because it can move around some. But you can thread that into either side of the Pico, whichever's more convenient. The sock does allow for exits on either side. so they just screw in hand tight. And the heater kind of goes towards the back, and you can slide your sock back on. And just a side tip on this thermistor, when I was using Marlin, that's the firmware I'm running for these tests, I chose number 11 for thermistors. It seemed to work out the best. This is a 100K thermistor inside here, but it stays really stable if you set it at that 11 thermistor number. Next, we can move on to loading up the hot end fan. It has this little metal shroud. It just slides on the heatsink right underneath that second rung. Just like that. And you might think this looks odd because it's a blower fan on its side, not a radial fan that you'd see on the other edge. That's so that they can use that blower to get as much air across that heatsink in that little defined area as possible. And these little 5-volt fans, it's more than enough to cool off this heatsink. It does a great job. I'll show you some FLIR footage here in a moment. When I had this mounted on my printer, I didn't originally have one of these groove mounts for the beta unit that I had. I actually used a PLA mount. I made it just a little bit longer so that it would be the same length as an actual V6. But I ran this for many, many hours. No problems at all. Even in PLA, the hot end runs cool enough, you're not going to have any issues. For direct drive setups, you get this little rubber cap that's going to fit in here flush. And then you'll have a piece of PTFE that goes down inside here. You want about 4 millimeters sticking out the top. I'm just using this section as an example. And then for Bowden, again, you get this metal coupler that will screw right down inside here. Designed to be used with that groove mount. And then you can mount up your tube. And you do get a larger clip that you can use, a plastic one. You can put it down inside this groove mount if you're using 3 millimeter filament. These are pretty easy to switch back and forth in between 175 and 3 millimeter. And just to give you an idea, there's a benchy for scale. So there's a quick look at the Pico and what comes in the box standard. And as with any good 3D printing company, they have add-on accessories that you can purchase. We're going to take a look at a few of those here in a moment. But if there's one thing that I can tell you about the Pico after working with it for several months, it's be careful with it. A lot of the parts that are machined are very thin, and that's by design so that it can do what it does. It heats up really fast, it cools down really quickly, and has a very sharp transition point, which can come in really handy in a 3D printer design. But it wouldn't be out of the scope if you tried to torque a nozzle down. You could shear it off at the heatsink. So just keep that in mind if you're going to work one of these into your project. So now let's move on and take a look at some of those accessories. One of the first ones that you're going to want to look at is the all-metal nozzle. Now this is for doing higher temp. It is made out of tool steel, but it has the throat or the barrel, whatever you'd like to call it, the brake, included on the nozzle. So it's all one piece, and it does go up inside that heatsink. So I'll take it apart once again just to show you, but there's no nozzle in that. And then when you put that all-metal nozzle in, you can see from the top it goes all the way to the top of that heatsink. And then from the side you can see it in those cross-drilled holes. And the next one that I find very handy is this adapter that they sell. With this adapter on top of your Pico, it's the exact same length as an E3D V6. And if you have a setup that you're already using a V6, go ahead and grab one of these because it makes it really easy to integrate your new hot end. You just take this groove mount off and you thread this longer one on. PTFE can go right down in there just like any other direct drive mount for this setup, and you're good to go. I told you about that one that I made out of PLA before. I made that and didn't even know that they had made these adapters. So it's good to know that we were thinking the same thing. Another add-on you're going to want to look at when you order your Pico is this built-in part cooling fan. It's just a metal shroud that screws in on your hot end fan, the one that comes with the kit. But that way you can add another 5-volt fan, it comes with it, to do your part cooling. There's no duct or anything, and you might think that that doesn't work really well for part cooling, but given what it is for a 5-volt fan, it does a really nice job. Just open like this with no duct. So consider that, because it does make a nice all-in-one package. You can see it there mounted on the side of the hot end. If you don't want to mess with fans and mounts, this might be the way to go. I kind of like it all concealed like that, so I can just take it off, put it on, switch it out to other printers. It all goes as one unit. And speaking of the part fan, let's talk about these linear voltage regulators. You do get one of these with the hot end for your hot end fan, and then if you add on that part cooler, you get another one exactly the same. It does convert the voltage down to 5 volt, but it also allows you to use PWM for that part fan, because we do like to spin those up and down in G-code at times. With a buck converter, you wouldn't be able to do that. So just a nice add-on. With any type of converter like this, it is very important to note, make sure you do not switch the polarity. I've had these things do some really unpredictable things when I got the input voltage flip-flopped, so double check that, because it will ruin these really fast. And just taking a quick look in the package, it's pretty obvious what the advantage to the Pico is going to be. Its size and its weight. For its size, it's going to have a lot of comparable features to a lot of different hot ends. But let's go ahead and run through a few and get some stats. So let's go ahead and run some comparisons here. So on the Pico, I'm going to include the block, the heatsink, and the mount. All the other hot ends, I'm going to leave the nozzle out, all that good stuff. Just compare raw weight. So the Pico, coming in at 11 grams. E3D V6, 31 grams. You can see it up next to the Pico. Pico is a little shorter. The Fetus Dragonfly BMO, 44 grams. This one is pretty much the same size as the V6. The Slice Engineering Mosquito Magnum, 39 to 40 grams. It is just a little shorter than the Pico. Slice Engineering Copperhead, 41 grams. Again, this one is relatively the same size as the V6. And just for fun, how about a V6 with a Volcano block, 33 grams. There it is, next to the Pico. So out of all the hot ends I had on hand, the Pico is definitely the smallest and the most lightweight. And if you were running a printer for maximum speed, this might be the hot end for you. I'd really like to see it on some sort of high-speed delta. Now, I've had a beta unit of one of these hot ends for a couple of months. I've been running it on my SK Go, and it's turned out really well. But I was kind of focused on a few things while testing it. Not so much throughput of the hot end. That can differ wildly depending on what you're going to do. But really how it's mounted, how it handles the heat dissipation, how the part cooling works, it being in this all-in-one design. So let's just have a look at it and see how I have it set up on this 3D printer. So here's the beta unit that I've been running on this 3D printer for a while. You can see I do have the combo fan, the hot end fan, and the part fan all in one. I've got the older style of sock. This one doesn't actually fit as well as the newer one that I showed you in the unpacking. The newer ones fit a lot more snug, plus mine's got a lot of time on it. I'm currently running the PTFE lined nozzle. I did do a lot of testing with both. And the longer V6 adapter. This was originally set up with a V6 clone. This is a Triangle Labs BMG. So this was a direct swap out after I added that adapter with that V6. It worked out really well. Now the whole voltage regulator thing, because these are 5-volt fans, kind of threw me a bit. It was a bit of a pain to get set up. I had to use those regulators, find a place to put them on the back of the printer, all of that. So I didn't like that so much when I put it together. But now that I have it installed, I think it's really nice to have these two fans right here on the side of the hot end. So the regulator might have been just a little bit annoying, but I think it's well worth it having all of this in one unit. It makes it much easier to deal with. You can just take it off, work on your hot end, slide it back on. I'm really starting to enjoy it. And again, even without a duct, that part fan does a pretty good job. One other side tip I can give you about this hot end when you're tuning it in, pay really close attention to your PID tune. Just because of the way that this is constructed, it's very thin, I've said that a million times, but when you do your PID, make sure you have your sock on. You might even want to kick your part fan on if you have one. Just get all that going at the same time, then do your tune. It's going to fluctuate greatly because of how fast it can cool down and heat up, so you want to have that as precise as possible. I'll leave a link of how to do an auto tune. Just look in the M303 command in Marlin. Here's a look at the hot end on FLIR. You can see where all that heat is focused down where it should be around the nozzle. And then up higher towards that heat sink, there's almost no heat at all. It's even kind of hard to tell where that heat sink is in the picture. You You see the tip of the screwdriver? It's right in here. Even if I pull the hot end fan off and just let it hang, you can see it slowly rise up here on the heatsink without that fan. But given what it is, so close to that heat block, it still stays relatively cool. And because it's so thin, it cools down really quickly. We can just slide that fan back on. With all that said, I wanted to put the hot end through its paces just a little bit. For the testing, I went with two plastics. PLA, so we could test out the nozzle with the PTFE liner, and ABS, so we could test out that all-metal nozzle that I showed you before. And I wanted the constant in these tests to be the temperature. 215 for PLA, 255 for ABS. You can get more throughput out of your hot end if you increase the temperature, but I wanted to kind of make that our baseline for all this testing and just go through the different speeds, step up, to see if maybe the hot end gives out at a certain point. So that's what I did next. Here's a look at our fleet of PLA tests. Again, I did PLA and ABS. I went all the way from slicer speed, 40 millimeters a second, all the way to 250 millimeters a second. Now remember, that is the slicer setting. It depends on the part shape, your firmware acceleration. Firmware acceleration for my machine was set to 2000 for all of these tests. So can it actually achieve that speed? Probably not, but they were all considerably faster, one after the other. And we do have a lot of different results. We don't have to take time looking at all these, but this is just a two-walled box. The seam is in the back, it's not vase mode, and it just has a couple of bottom layers. Print quality, 40 millimeters a second. It's just fine, as you would expect, no issues at all. With that smaller part cooling fan, that is one of the factors that I wanted to test. When does it start not to be adequate enough? This is 100 millimeters a second. You can see the corners are still nice and sharp. No problems there. But then you move to 120, then they start to get pretty rough. And they continue to get rougher as you move the speed up. Now remember, on the PLA test, we were at 215 on all these. You can increase the temperature to get more flow out of that filament. But because of part cooling, the speed we were going at, this is 250 millimeters a second. When we get down to here, you can see the corners are really, really rough, and we're starting to miss out on some of the extrusion. You can see what the back looks like here. So that's not saying we were maxing out that hot end, but at that temperature, it was starting to get pretty light. Same print, same speeds, only we were at ABS, 255C, which is kind of high. This is pretty affordable inland brand ABS that I just had laying around. Again, 40 millimeters a second, 250 millimeters a second. 40 looks just fine. It is bowed out because, you know, it's ABS. It likes to shrink as it's printing, but it completed. For ABS, this is what I would expect for a two-wall print. The quicker you go, it actually does smooth out a little bit because it doesn't have near as much time to bow. All of these prints look pretty good. We started to get a little thin at 120 millimeters a second in one of the corners, but nothing too outrageous. Still looks decent. And then we go all the way up to 250. You can see that corner is pretty rough, but for the speed that it was traveling at, the print came out pretty well. And the reason why the ABS one looks so much different is because we were printing at a higher temp. There's no part cooling, so that higher temp is going to allow it to flow more filament. And you've probably seen this a lot before. People printing high speed, they're probably printing something like ABS. Here's the 250 millimeter a second ABS run. You can hear the belt rub. I need to tune that out, but it only happens when you get up towards these speeds. I don't know that that's true 250 millimeters a second, but it's definitely moving. And of course you knew I was going to show you a benchy, but the overhang looks good. That part cooling fan is doing just fine. The print looks really nice overall. No problems to speak of. After all the testing, I have to say that I really like the Pico Hybrid. I like the design choices they've made. The one drawback that I can see is how delicate it is. You've probably seen me work on things before. I'm not the most careful with things, and that doesn't go well with a design like this on the Pico. But after you get it all set up, you're familiar with it, you realize you don't have to torque the nozzles like you would on a regular hot end, it's going to work out just fine. And because it's machined that way, it's going to give you all the advantages of this design. That's why they did it. You can have a really sharp transition temperature, that heat sink stays really cool. It's a very small package, so you can fit it on different printers without wasting any build volume. And it's very lightweight, so you could possibly go really, really fast with one of these hot ends. This might be the hot end for all you Voron folks out there. You'll definitely have to check it out. And of course we have to mention price. Now these are going to come on sale for around $150, what you saw in that tin. And then you can add things on from there. But with a hot end company like this, just getting their feet underneath them, that's probably not all that far out of scope. So if you're looking for a hot end, definitely check this one out. Now, this hot end was given to me free of charge. There was no money that exchanged hands, and all opinions expressed are my own. Good luck to the Metaform folks. I think they're going to do a great job on this. That will be it for today. Hopefully you found this helpful, and I'll see you really soon on the next one.